The last thing then that I want to talk about is how dilations of solids relate to volumes. Okay. So we've talked all this. We've talked in a number of chapters about dilations, right? And we use the following ratios. If the ratio of parts is n to n, then the ratio of areas is that ratio squared. Okay. It's that ratio of parts is going to be applied for every dimension that you're measuring. So an area is 2 dimensions, so you're going to square it. And we've, again, addressed this, but now that we're dealing with solids or 3 dimensions, we're going to take the ratio of parts. And if we're looking to relate it to a volume, we'll cube that. A volume's 3 dimensions, so you're going to cube that ratio. Okay. Now, if I just give you a straightforward ratio of parts, so if I tell you that you dilate a cube by a factor of 3, how does its surface area change? Surface area changes by a factor of what? Surface area is a 2-dimensional measurement, so it's going to be, again, if you kind of think, parts is 1 to 3 or 3 to 1. That means areas is going to be 1 to 9. So its surface area will change by a factor of 9, or 3 squared. What's the volume going to change by? By a factor of, again, 1 cubed to 3 cubed. So the volume is going to change by a factor of 27. Now the place, so this one is this is as straightforward as you can get relating these concepts. Okay, to make it a little more challenging, sometimes I might tell you that the ratio of the surface areas of 2 cubes. So if I say the surface area of 2 cubes, and I choose cubes because all cubes will be similar. Their faces are all squares. Okay, so any 2 cubes will be similar to one another. So the surface area of 2 cubes has a ratio of 4 to 25. What is the ratio of their volumes? And so this would be the more challenging way that you might see this type of information presented. And the challenge is you have to go backwards to go forward in a problem like this. And so if you were told you have these similar figures and you're given the ratio of, it should be surface area. If you're given the ratio of their area, so here's what you started with. The areas are 4 to 25. You can't just jump straight to volumes. It's not like a volume is, you're not squaring the ratio of areas. What you're doing is you're cubing the ratio of parts. So you have to go backwards first. Okay, so if we know that the ratio of their areas is 4 to 25, what does that mean the ratio of their parts is? 2 to 5. And once you find the ratio of parts, now you can move forward and cube it. So 2 cubed is 8, 5 cubed, 125. And so that would tell you what your ratio is, either 8 over 125 or 125 over 8 if you needed to use a scaling factor for that.